Before we move any further here, I need to make one correction from the previous video. In my muscle model function here, if I scroll down to line 73, I no longer need to know the CC force for each muscle. I just need to know the SEC force down here when I'm updating the joint moments. So I'm going to stop indexing my CC force, so I'm going to stop storing it for each muscle. And then, more importantly, down here on line 79, where I am calculating the value of my force velocity factor, the numerator there needs to be the CC force, not the SEC force. Recall this equation here on line 79 came from our definition of the CC force, which is the max isometric force times activation times force length times force velocity. By setting the left-hand side here equal to FSEC, what I was assuming there was that the CC force and the SEC force are equal. That's only the case when our pronation angle is 0, which makes this cosine 1 and makes the CC force actually equal to the SEC force. Now that we've added a pronation angle, we can't make that assumption anymore. The CC force is no longer necessarily equal to the SEC force. So when I'm calculating where I am on force velocity down here, I need to use the correct force in there, which is the CC force. And so that's why the numerator here on line 79 needs to be the CC force, not the SEC force. So make sure you correct that in your own code as well. Okay, we have a few tasks remaining to us before we can perform a muscle-actuated forward dynamics simulation. We need to, one, parameterize our muscle models. We need to define the muscle excitations, and we need to determine the initial states of the muscles, an initial value for activation and for CC length for each of the muscles in our model. Let's knock out defining these muscle excitations first, because that's a fairly simple thing, at least can be a fairly simple thing. What we are eventually going to study here, what we are eventually going to simulate, is a vertical jumping motion. The model is going to start in some initial squatted posture, and then it's going to activate its muscles to try to jump as high as it possibly can. That motion is well simulated with a control scheme that's called bang-on controls, where the muscle excitations start at some initial value, and then at a particular time, they switch abruptly from that initial value to their maximum value, which in this case would be 1 or 100% muscle excitation. So to simulate that sort of bang-on control, I'm going to define here a global set of parameters here for our excitations called upars. And then in my simulation settings, I'm going to define some values for upars. My first entry here in upars is going to be the time within my simulation time here where the gluteus muscle switches from its initial value to its maximum value. And we'll just make these up for now. We'll say that that time is 0.5 seconds. So time at which gluteus bangs on. And then we'll do the same thing for our vasti muscle, and we will have that bang on at 0.6 seconds. And then I'm also going to define those initial excitations for those muscles. And I'm going to set those equal to a value u min, which I haven't defined yet. I'll do that in a little bit. So this is my initial excitation for gluteus. And upars 4 is going to be my initial excitation for vasti. Then over here in my parameters, let's add a value for u min, the minimum muscle excitation, and we'll make that a little bit above 0. Remember, we don't want the excitation and activation to ever literally get to 0. That causes numerical problems in our muscle model, so we'll make it something close to 0. Okay, now I've got my excitation parameters defined. I have them defined as global so that I can pass them to my function here, my model state equations. And then down here on line 54 is where I was defining my muscle excitations. So the way that we model these bang-on controls is, let's first label my control variables. And the times on, or T on, is going to be those first two values in UPAR. And the initial excitations, or U naught, is going to be those second two values in UPARs. So these are my bang on times. And these are my initial muscle excitations. Okay. And then the way we model bang on control here is I check what the current time is. Remember, time is one of my entries in here into this argument for this model, a set of model functions. If the current time is less than the bang on time for this particular muscle, then I set that muscle excitation equal to its initial value. Otherwise, if the time is beyond the bang on time, then I set that muscle's excitation equal to its maximal value, so to its maximum excitation. So simple enough there. And now we are ready to go to our list of tasks here. And we no longer need our muscle excitations on there. So 2 steps remaining to us. We need to parameterize our muscle models, and we need to determine our initial muscle states. Let's bite-size this a little bit and make each one of these a separate video. So I will stop this one here, and then next time we will parameterize the muscle models.